All right, in 8.4, we're going to be learning about the binomial theorem. So a binomial is something that has two terms. So we've all seen a binomial before. It's going to be raised to some power, and we're going to figure out a nice little shortcut on how to multiply all of this out. So it's kind of just like foiling, but big time. But we're going to learn some shortcuts, which we'll get to that on the second page. But right now we're just looking at this formula here. So we're going to be given a number and another number, and we just plug them into this formula. So we have the factorial of n over n minus r factorial times r factorial. And just as n comes before r in the alphabet, n comes first here in the NCR. So n comes first. We're going to see the problems written like this, where we have NCR, or we'll have it like this, where we have n on top of r. But for both of them, we use the same formula. So let's do some examples. Let's look at example A. So we have 8C2. Which ones are n? 8. So this one's n. 2 is our r. So we just take 8 and 2 and plug it into our formula over here. So we have 8 factorial over 8 minus 2 factorial 2 factorial. We can simplify. 8 factorial over 6 factorial 2 factorial. And now we can solve. So anybody remember what the factorial means? Awesome. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. And then we cancel out anything that is in common. So we have 6 and 6, 5, 5, 4 and 4, 3s, 2s, 1s. So then we're just left with 8 times 7 on the top and 2 on the bottom. You don't even need to write the ones because 1 times anything is itself. So what's 8 times 7? 56 over 2. And 56 divided by 2 is? Yeah, 28. All right, let's do B. So which one is our n and which one's our r? Ten is n and 3 is r. So we plug it in. We have 10 factorial over 10 minus 3 factorial times 3 factorial. So 10 factorial over 7 factorial times 3 factorial. Let's work it out. On top, we have 10 times 9 times 8 times 7. I'm just going to say 7 factorial because I know that 7 going down is going to cancel out with my 7 factorial on the bottom. So this 7 factorial is like saying 7 times 6 times 5 times 4 times 3 times 2 times 1. Same with this one, so these just cancel out. They're the same thing. So on top, I'm left with 10 times 9 times 8 Anybody know what 10 times 9 times 8 is? 720. And then on the bottom I have 6. What's 720 divided by 6? 120. Perfect. I'm going to go to example 2, but just before I move on, let's look at C. Okay, for C, our N is 7 and our R is 0. What is 0 factorial? Nope. 0 factorial is 1. So just remember that when doing these. 0 factorial is 1. Okay, let's look at example 2. So these are doing the same thing. For A, what's our N? Our N is 7 and our R is 3. So we just plug that in. We have 7 factorial over 7 minus 3 would give us 4 factorial times 3 factorial. That's the formula. Oh yeah, we're doing A on example 2. So on top we have 7 times 6 times 5 times 4 factorial, because I know that everything after 4 is going to cancel out with my 4 factorial on the bottom. So 4 factorial cancels out with 4 factorial. 3 factorial is 3 times 2. And 3 times 2 is what? 6. So 3 times 2 is going to cancel out with 6 on the top. So then what am I left with? Seven times 5. That's all I have left on the top. Nothing on the bottom. 35. All right, let's do one more from example 2. You can pick B, C, or D. All right, let's do B. You said B? Oh, D. One factorial is just 1. So 0 factorial and 1 factorial are both 1. So for D, what's our N and what's our R? Awesome. 12 is N, 11 is R. So we have 12 factorial on the top over N minus R factorial, so 12 minus 11, which would give us 1 factorial over, or times 11 factorial. So on the top, I have 12 times 11 factorial, because I could keep going, but I see that I have 11 factorial on the bottom, so I know that'll cancel out. And 1 factorial is just 1. So I have 12 times 11 factorial on top, 1 times 11 factorial on the bottom. These cancel. So then I'm just left with what? 12. Alright, next. We have this thing called Pascal's triangle. Anybody remember this from Algebra 2? Alright, a couple people. Well, we use Pascal's triangle to help us find the coefficients of our binomials. So we have this row down here. So these two triangles are pretty much the same thing. The one on the bottom just has like x's and y's in it, so it just shows you how each one is the coefficient. If we have x plus y squared, we're looking at the second row of our triangle, and these are our coefficients here. if we take x plus y to the fourth power, we're looking at the fourth row, and these are our coefficients, 1, 4, 6, 4, and 1. They come up with the coefficients by adding the two numbers right above it. So looking at this triangle, we have 1 plus 2 here. That gave us 3. We have 6 plus 4 here. That gives us 10. 4 plus 1 here is 5. So just by adding the two numbers directly above it is how they get the next row of the triangle. So we could write the 8th row here. Always start with a 1, and then we have 1 plus 7, which would be 8. And then 7 plus 21, 28. 21 plus 35, 56. 35 plus 35, 70. 35 plus 21, 56. 21 plus 7, 28. And 7 plus 1, 8. Then we always end with a 1 also. And then whatever the second number is, that tells you what row you're looking at. So here we have the second row, even though it kind of looks like the third row because we just have that 1 up top, but we can kind of ignore that. If the second number is 3, this is our third row. Second number is 4, this is our fourth row. Fifth row, sixth row, and so on. So now we're going to use Pascal's triangle to write the expansion of the expression. So here we could multiply x plus 1 times x plus 1 times x plus 1. We would have to FOIL these two out, get an answer, then FOIL that out with the other one, and it would just be a lot of work. Pascal's triangle is a shortcut to kind of eliminate all that work and possibility of error as well. So we start our expansion by looking at our exponent. So we have the third power. So we're looking at the third row of Pascal's triangle. So our coefficients are 1. My pencil just fell asleep. We have 1, 3, 3, and 1. So we're looking at the third row because it's x plus 1 cubed. Our next step is just to take our first term and write it under all of our coefficients. So we have x, 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 and x. And then we take our second term and write it under our first term. So 1, 1, 1, and 1. Then we start with our coefficients. So we start with our exponents. So whatever this exponent is, our x starts with that, and then we descend there. So we start x cubed, then x squared, x to the first power, x to the power of 0. For our second term, we start at the number all the way to the right. That gets cubed, and then we go down from there. 2, 1, 0. Now we multiply all of our columns together and simplify. So we have 1 times x cubed. What's 1 to the power of 0? Just 1. So 1 times x cubed times 1 would be x cubed. Then we have 3 times x squared times 1, which would be what? 3x squared. And then 3 times x times 1 squared is 3x. What's x to the power of 0? 1. So 1 times 1 times 1 cubed, just 1. And this is our answer. A whole lot less work than foiling it all out. Especially when you start to get to like your binomial to the 4th power to the 5th power. Let's look at example 4. So which row of Pascal's triangle are we looking at? The 3rd row, because our exponent is 3. What are the coefficients in our 3rd row? 1, 3, 3, 1. Then we have our x term, so x, 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 and x. We start with x cubed, then squared, then x to the 1st power, then x to the power of 0. What's our second term? Negative 1. So we have negative 1, negative 1, negative 1, negative 1. We start all the way to the right, and this one's going to be cubed. That means this one's squared, this one's to the power of 1, and this negative 1 is to the power of 0. I put them in parentheses just so you can see that that negative is what's being cubed, that negative is also being squared, so that negative is included in that power. So it helps me just to put it in parentheses so I can see. So this term, x to the power of 0 and negative 1 to the power of 0, they're just 1. You can cross them out if you want to. You could leave them there if you just know that they're 1. I like to cross them out so I don't accidentally write it again. And now I'm just going to combine my columns. So what's 1 times x cubed? X cubed. Next I have 3 times x squared times negative 1 to the 1st power. Awesome, negative 3x squared. What about 3 times x times negative 1 to the 2nd power? Perfect. Negative 1 to the 2nd power is positive 1, so this would be positive 3x. And then 1 times negative 1 cubed? Awesome, negative 1. Whenever you have a negative, so like whenever you're binomial, you're subtracting, your signs are always going to alternate. So you'll never have like 2 negatives in a row. It's always going to go plus, minus, and just keep going. Alright, let's look at example 5a. Which row are we looking at in our Pascal's triangle now? The 4th row. What are the coefficients in the 4th row? 1, 4, 6, 4, 1. What's our first term? 2x. We have 2x, 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 and 2x. Our first 2x, all the way to the left, what exponent is that going to have on it? To the 4th power. Perfect. We start with whatever our exponent is in the original equation. So 2x to the 4th power. Next we have 2x cubed, 2x squared, 2x to the 1st power, 2x to the power of 0. What's our second term? Negative 3. So negative 3, negative 3, negative 3, negative 3, negative 3. So negative 3 all the way to the right is going to have the 4th power, and then we descend going left. So this would be cubed, squared, 1st power, power of 0. I like to cancel out my powers of zeros and then just work with my columns. What is 2x to the 4th power? So it is 2 that needs the exponent of 4 and x that needs that exponent of 4. So we have 2 to the 4th power, which would be 2 times 2 times 2 times 2. What would that be? Two times 2 is 4. 2 times 2 is 4, and 4 times 4 is 16. So this is 16x to the 4th power. And 16x to the 4th power times 1 would just be 16x to the 4th power. Next, we have 2x cubed. So the 2 is cubed and the x is cubed. So 2 cubed would just be 2 times 2 times 2, which would be 8. So this is 8x to the 3rd power. So we have to multiply our coefficients together. So 4 times 8 times negative 3 would be what? -96. Negative 96. And then x cubed. All right, next. What is 2x squared? 4x squared. And then what's negative 3 squared? 9. So we have 6 times 4 times 9. So 216 x squared. Perfect. And then next, we have 4. 2x is to the 1st power is just going to be 2x. What about negative x cubed? Or negative 3x, negative 3 cubed, I'm sorry. Perfect. Negative 27. So we have 4 times 2 times negative 27. Negative 216 x. Perfect. And then the last column, we have 1 times negative 3 to the 4th power. Positive or negative? Positive, 81. And you can always check your signs just by making sure that they alternate. So this one's positive, negative, positive, negative, positive. They're always going to alternate. All right, let's look at B. Here we have x minus 2y to the 5th power. So which row are we looking at now? The 5th row. What are our coefficients in the 5th row? 1, 5, 10, 10, 5, 1. And then our first term is x. So we start x. X, 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 and x. What's our x all the way to the left? What exponent is going to be on that x? Perfect. X to the 5th power, 4th, 3rd, 2nd, 1st, 0. What's our second term? Negative 2y. Negative 2y. Negative 2y, negative 2y. So for the second term, we start all the way to the right. That's going to have the 5th power, 4th, 3rd, 2nd, 1st, and 0. I'm going to cross the zeros out because we don't need them. And let's multiply our columns. What is 1 times x to the 5th power? X to the 5th power. Next, we have 5 times x to the 4th power times negative 2y. So we want to just multiply our coefficients first. So we have 5 times negative 2, which would be what? Negative 10. And then we have x to the 4th power times y to the 1st power. Alright, next one. So we have 10 times x cubed times negative 2y squared. Let's simplify negative 2y squared first. What's negative 2y squared? Perfect. This is 4y squared. So let's multiply our coefficients. 10 times 4 is 40. And then we have x cubed and y squared. Alright, next. 10 times x squared times negative 2y cubed. Let's simplify our negative 2y cubed. Awesome, negative 8y cubed. Multiply our coefficients, so 10 times negative 8, negative 80, x squared y cubed. Next, let's simplify negative 2 times y to the 4th power. Awesome, 16y to the 4th power. And what's 5 times 16? 80. 80x times y to the 4th power. And then last, 1 times negative 2y to the 5th power. What's negative 2 to the 5th power? Negative 32. And then y to the 5th power. 1 times negative 2 times y to the 5th power is just negative 32 y to the 5th power. So that's our answer.